Blockchain networks differ mainly in who can join, who governs them, and how visible their activity is. Public, private, and permissioned models each solve different trust problems. In this module, we'll see how Hyperledger Besu supports these choices across Ethereum-compatible environments. We've already established what Hyperledger Besu is and where it fits in Ethereum and enterprise settings. Now we'll look at the network models it can support, because each one changes the way access, trust, governance, and deployment decisions are handled. Choosing a blockchain model sets the rules for trust, visibility, and control. A public network favors openness. Many participants can read, submit, and validate activity, but privacy and governance are harder to constrain. A private network narrows participation around organizational boundaries, improving control and confidentiality. A permission network sits between them, allowing known participants to operate under formal access and governance rules. This choice should come early, before architecture decisions become difficult to change. A public Ethereum network is not owned or controlled by one organization. Anyone can inspect the ledger, send transactions, build applications, or operate infrastructure. In this environment, Besu acts as an execution client. It processes transactions, maintains Ethereum state, and communicates with other compatible nodes. Open participation also creates shared responsibility. To remain connected and useful, each node must follow public network protocols, client standards, and operational expectations. In public Ethereum, consensus and execution are separate responsibilities. Validators, through a consensus client, decide who proposes a block and who attests that it follows the chain rules. Besu handles execution. It runs the EVM, applies transactions, updates account and contract state, and returns execution results through the engine API. That is why a public node commonly pairs Besu with a consensus client. Together, they produce valid blocks and stay synchronized with the Ethereum network. Public networks are powerful because trust is distributed across many independent participants. Anyone can inspect activity, verify records, and reduce reliance on a single operator. The trade-off is that this openness may not fit every enterprise requirement. Some organizations need private data, predictable fees, controlled access, and clear governance authority. So the key question is not whether public networks are better, but whether their openness fits the business requirements and risk model. A private Besu network uses Ethereum technology inside a controlled business boundary. Instead of open participation, the operators decide who can run nodes, connect applications, and access endpoints such as JSON RPC or WebSocket. The network is usually isolated from public Ethereum, unless an integration is deliberately added. This model works well when organizations need shared blockchain logic, while still maintaining governance, infrastructure control, privacy expectations, and predictable operations for pilots, consortium processes, or internal systems. Consensus in a private Besu network is not one size fits all. The organization defines who can validate blocks, and that choice reflects its trust model, governance process, and performance goals. Because participants are known, mechanisms such as click or IBFT become practical. The trade-off is important. Faster finality and higher throughput can also bring more operational responsibility. In this setting, consensus becomes a business design decision, not just a protocol setting. Private networks are useful when an organization wants blockchain coordination without public network exposure. The main trade-off is responsibility. You decide where nodes run, who can operate them, how keys are protected, and how changes are approved. That could mean on-premises infrastructure, cloud hosting, or a consortium model shared across partners. Isolation reduces outside traffic and public chain volatility, but it also means your team owns monitoring, backups, security, and upgrades. It is a controlled environment for testing before production. Permission networks add a control layer around blockchain participation. Instead of assuming anyone can join, transact, or administer, the network checks explicit rules first. Those rules can apply to nodes, accounts, APIs, and operational actions. This is especially useful in private or consortium environments, where governance, auditability, and security requirements matter. Besu supports these permissioning patterns, helping enterprises align blockchain access with real organizational policy. Node permissioning is the network's gatekeeping layer. Before a peer can connect, the operator requests membership, proves its identity, and is reviewed against consortium policy. If approved, that node is added to an allow list and can communicate with other trusted peers. If it is unknown, misconfigured, or no longer authorized, it is blocked or suspended. The key point is that membership is not only technical. Governance decides who belongs, and operations keep that decision enforced. Think of account permissioning like badge access in a secure office. The blockchain account is the badge, and each transaction is a request to enter a protected area. Before that request changes the ledger, the permissioning layer checks whether the account is allowed to act. Those accounts may belong to people, applications, services, or organizations. This control only works if keys are protected and roles are assigned carefully. In a permission network, governance is the operating system behind the technology. It defines who can approve new participants, remove members, change validators, grant node access, and respond when rules are broken. This matters even more in consortium settings, where no single company should control every decision. Clear governance turns trust into process. It reduces disputes, makes upgrades safer, and gives the network a stable way to handle change over time. Choosing a blockchain model is ultimately an architecture decision. Public networks fit when transparency, broad verification, and ecosystem reach matter most. Private networks fit when an organization needs isolation, performance tuning, and tighter operational control. Permission models fit when known participants must follow defined access and governance rules. In enterprise settings, the answer is often hybrid. Private infrastructure combined with permissioning, so the business can protect sensitive data while still creating shared trust across approved participants. Besu can support several enterprise network models. Public networks maximize openness and Ethereum ecosystem participation. Private networks provide controlled, configurable environments. Permission networks add governance over who can run nodes and use accounts. Next, we'll connect these models to Besu's value, and when it is, or isn't, the right choice.